Beneath the shadows of Geneva, far below the surface of the Earth, lies a stunning triumph of human ingenuity, and an unavoidable sign of potential destruction. The Large Hadron Collider, or LHC, is a marvel of intelligent analysis, allowing researchers to investigate the subatomic realm and leading to the discovery of the elusive Higgs boson, more commonly known as the God particle. This breakthrough has captivated the scientific world. Yet, as Brian Cox, a well-known physicist, ominously declared, a hidden potential has been found at CERN, triggering a wave of wonder and worry. Could our quest for knowledge be taking us down a dangerous path? Have we chosen a course that leads to an uncertain future, one possibly beyond our comprehension? Before exploring this startling possibility further, it is necessary to take a closer look at the gigantic machine that is the Large Hadron Collider, managed by CERN. The LHC is a massive 17-mile, 27-kilometer, ring made up of superconductive magnets. It is, without a doubt, the largest and most powerful particle accelerator ever developed. It represents the pinnacle of scientific achievement, capable of recreating conditions that rival those of the universe's very creation. This amazing piece of equipment allows researchers to investigate the fundamental components of the cosmos, components that could empower humanity tremendously, but also bring about unanticipated effects, potentially leading us into uncharted and terrifying territory. Founded in 1954, CERN has grown into one of the most important and prestigious research centers in the world, with 23 member countries and a vast international network of experts. While the LHC is the most well-known project, it is only one part of an expansive array of accelerators and detectors aimed at understanding the smallest building blocks of the universe. The LHC speeds up protons to nearly the speed of light, causing them to collide in a course that mimics the energy flow and conditions of the universe's inception. The temperatures produced in these collisions are millions of times hotter than the Sun's core, while an intricate web of magnets directs these particles in a highly synchronized path. Meanwhile, sophisticated cooling techniques maintain the collider's ultra-cold environment, colder, even, than outer space. Furnished with 1,232 dipole magnets to guide the proton beams and 392 quadrupole magnets to focus them, the collider increases the probability of collisions with incredible precision. The mission is so exact that it's comparable to hitting two needles placed 6 meters apart. The technology required is staggering, and the construction, deep underground in concentric rings, protects the system from harmful radiation to ensure optimal performance. The entire setup is cooled to -456 degrees Fahrenheit, colder than space itself, and contains 4 main particle detectors, ATLAS, CMS, ALICE, and LHCb, each designed to investigate different aspects of particle physics. These massive sensors act as cameras, capturing particle interactions and helping experts search for traces of the Higgs boson, a mysterious particle thought to be integral to understanding the fundamental structure of the universe. By understanding the microcosm, we begin to decipher the macrocosm, piecing together a cryptic cosmic puzzle. But with every new piece comes new mysteries and questions. Each discovery leads to another challenge. The LHC is not merely a scientific tool, it is an embodiment of human ambition, progress, and our relentless drive to understand the fundamental forces that shape reality. However, as we dive into the unknown, we must also confront the moral and existential dilemmas that come with such brave investigation. What are the risks of delving into the unseen? Could our pursuit of understanding unleash forces beyond our control? Recently, a disturbing revelation sent shockwaves through the scientific community. Brian Cox, a former CERN researcher and prominent voice in particle physics, made a statement that both intrigued and alarmed his colleagues. According to Cox, the LHC's mission to recreate a version of the Big Bang, reproducing the very event that birthed our universe, could result in unforeseen consequences. The collider's impressive ability to investigate the depths of the Higgs boson and the dark enigma of dark matter, a substance that constitutes a significant portion of the universe, could potentially reveal information beyond human comprehension. While locating the darkest mysteries of the universe is exhilarating, it also comes with immense risk. The LHC recreates extreme conditions that prevailed at the universe's inception, temperatures, pressures, and energies unlike anything observed in everyday life. It's as if we are peering directly into the moment the universe began. But such enormous power comes with enormous responsibility. Consider the incident involving Russian physicist Anatoly Bugorsky in 1978. While conducting research at a high-energy synchrotron in the US, a proton beam accidentally passed through his skull, causing serious tissue damage. Miraculously, he remained conscious and sought medical attention. His experience serves as a stark reminder of the potential dangers associated with the power harnessed by particle accelerators. The force within these machines should never be underestimated. Concerns have arisen over the LHC's ability to create black holes, even on a very small scale. Some scientists fear these miniature black holes could theoretically consume the Earth from the inside. Though researchers at CERN have assured the public that any black holes generated would evaporate almost instantly and pose no threat, the very idea has sparked both curiosity and fear. The concept of forming a black hole through high-energy particle collisions has fueled extensive debate, raising awareness of the dangers such powerful experiments could pose. Understanding the LHC's mechanisms is crucial to grasp its potential to create such anomalies. When protons are accelerated to near-light speed, the energy produced is so intense that it can warp the fabric of spacetime, similar to how jumping on a trampoline bends its surface. These distortions raise an unsettling question: could such a shift form a black hole? In the strange and mind-bending realm of quantum physics, where the universe's fundamental laws appear to defy logic, theories suggest unknown aspects of our reality may conceal deeper truths. If such hidden components exist, the LHC could potentially tap into them, sparking the formation of a gravitational anomaly, or even a black hole. This possibility has attracted attention from some of the world's most respected scientists, including the late Stephen Hawking. In his writings, Hawking warned of the potential dangers of the LHC, particularly if the Higgs boson behaves unpredictably at high energy levels. Such anomalies could trigger catastrophic events like vacuum decay, which may not only destroy Earth but unravel the very fabric of the universe. Renowned cosmologist Sir Martin Rees also acknowledged the risks associated with particle accelerators. In his work on the future of humanity, he suggested that CERN's experiments could potentially cause vacuum instability, an unimaginable occurrence that could result in catastrophic changes to spacetime itself. Though the likelihood of such an event is minimal, the repercussions would be catastrophic. CERN researchers are fully aware of these dangers and have taken extensive safety measures to minimize potential threats. Still, the nature of the question that now looms over us is not just whether we can unlock the universe's deepest secrets, but whether we should. Every advancement comes with a price, and when that advancement dances on the edge of cosmic power, the stakes rise exponentially. One must ask, what are we really searching for? Is it the origin of life, the architecture of spacetime, or perhaps the elusive theory of everything that Einstein once dreamt of? If we reach the end of that search, will we finally grasp the full scope of reality, or will we be forced to confront a truth so vast, so alien, that it reshapes what it means to be human? Already, some philosophical thinkers and theoretical physicists warn of a future where our reach exceeds our grasp. They envision a moment in which a single miscalculation, a singular chain reaction initiated by a particle collision, could create an irreversible cascade through space and time. Not from malice, but from the innocent pursuit of knowledge. In this context, the LHC begins to resemble not just a scientific marvel, but a modern-day Pandora's box. We open it not with curiosity alone, but with hope, and perhaps a tinge of hubris. Recent upgrades to the collider, aimed at increasing its luminosity and collision frequency, promise to deepen our understanding of quantum phenomena. But they also intensify the very conditions that raise concern. These upgrades are designed to answer questions that have baffled scientists for generations. Why does the universe prefer matter over antimatter? What is the nature of dark energy, the invisible force accelerating the expansion of the cosmos? Could there be additional dimensions folded into the very fabric of our reality, hidden from sight but accessible through high-energy events? Each question draws us closer to what some call the edge of physics, a point beyond which our current models may break down completely. If those models break, what emerges in their place? It's not unreasonable to imagine that future generations will look back on this era with awe. Perhaps they'll praise us as pioneers, brave enough to challenge the unknown. Or perhaps they'll curse our arrogance, wondering why we risked the known world for the promise of abstract truths. The ethical dilemma becomes unavoidable. In a world still plagued by war, hunger, inequality, and environmental collapse, should we divert such vast intellectual and financial resources toward the pursuit of cosmic riddles? Or does the pursuit itself represent our highest aspiration, to transcend the mundane, to seek knowledge not because it is profitable, but because it is right? Brian Cox, in one of his most reflective interviews, once said, "Science is not just about facts. It's about understanding our place in the universe." That, perhaps, is the ultimate justification. But understanding comes with responsibility. The Large Hadron Collider is a gateway, to enlightenment or to consequences we may not yet be equipped to manage. It asks us to be bold, but also to be wise. We now stand at a precipice. What lies beyond may be the next great chapter in human history, or its final footnote. The LHC's scientific discovery is still an exceptional illustration of our desire to understand the universe. The sheer scale of the project reveals a great deal about the over 10,000 aims behind it. Technicians, engineers, and scientists from all over collaborate with CERN to ensure the success of the machine. The scale of the LHC's data collection is staggering, with experiments generating petabytes of data every year. The storage and processing power needed to deal with this colossal quantity of data demanded cutting-edge technology that revolutionized fields like computer science and data science. The LHC experiments go far beyond particle physics, extending into areas like materials science, medicine, and environmental studies. For instance, they could have wide-ranging consequences that go beyond our comprehension of the universe. The Higgs boson, a fundamental part of the standard model of particle physics, is an important part of distributing mass to other particles. Without the Higgs field, the universe would vastly expand, with scattered particles in a state devoid of population. Beyond fundamental comprehension, scientists are eager to understand the particles' behavior under extreme conditions. These studies could result in important insights into everything from the development of new materials to comprehending the fundamental factors that determine the universe. One of the LHC's most notable investigations is into the invisible substance known as dark matter, a substance that makes up about 27% of the universe's mass-energy content. Despite its enormous influence, scientists have not yet detected dark matter directly. The LHC's experiments aim to reveal the potential particles that may constitute dark matter by observing the behavior of particles generated during high-energy collisions. If dark matter is finally confirmed, it might alter how we see the unfolding of the universe, spacetime's hidden dimensions, and the foundations of modern physics. Alongside dark matter, the LHC is also exploring other exotic realms such as supersymmetry and the potential existence of additional spatial dimensions. A theory called supersymmetry makes a connection between two fundamental classes of particles, bosons and fermions. It predicts the existence of superpartner particles that haven't yet been observed. If found, supersymmetry could open the door to a fresh perspective on the fundamental forces of nature, offering deeper insight into the interactions that control our environment. Additionally, the LHC is essential in moving quantum computing forward. By understanding the behavior of subatomic particles, scientists can gain insights that have the potential to transform how we process quantum information. Computers operating according to the theory of quantum mechanics may solve problems currently beyond the reach of classical computers. Technologies created specifically for the LHC's experiments, such as specialized sensors and cutting-edge computing algorithms, have already advanced the field of quantum computing. Despite its limitations, the LHC paves the way for future breakthroughs. Yet, its work also raises fundamental questions about humanity's future. The search for the unknown can be thrilling, but it comes with the responsibility of considering potential unintended consequences. The very technology that drives the LHC could also be used for purposes harmful to humanity, such as the development of advanced weapons or ethically questionable experiments. Ethical debates surrounding the LHC are not limited to the possibility of catastrophic events like black holes or vacuum decay. They also include concerns about how the research is used. How can we ensure that this knowledge is used responsibly and that the search for truth does not inadvertently lead to harm? As we explore the unknown, it is crucial to engage in ongoing discussions about the balance between ethical progress and scientific advancement. The global nature of the LHC's work necessitates cooperation between multiple countries, each with its own values, priorities, and concerns. Transparency, accountability, and international collaboration will be essential in ensuring that the information gleaned from these experiments benefits the entire human race, rather than causing unanticipated harm. Through the LHC, CERN's efforts serve as a reminder that scientific achievement must always be tempered with careful consideration of its broader consequences. An additional cause for concern is the potential for unforeseen ecological effects. While the LHC is relatively small and designed to minimize environmental impact, the enormous amount of energy required for such machines should not be overlooked. The environmental impact of particle accelerators, particularly those consuming vast quantities of electricity and generating heat, could strain natural resources and ecosystems. The energy demands of the LHC are immense. Although efforts are underway to use renewable energy sources and improve efficiency, the broader issue of sustainable scientific exploration remains. In the end, the path forward requires a delicate balance. The LHC represents humanity's drive for knowledge, exploration, and discovery. However, with every scientific breakthrough comes the need for ethical reflection and responsibility. The risks involved in such experiments cannot be ignored, but the potential rewards could reshape our perception of the universe in unimaginable ways. As we move forward on this journey into the unknown, our focus must be on ensuring that scientific progress is made safely, responsibly, and for the benefit of future generations. In conclusion, the Large Hadron Collider is far more than a tool for scientific investigation. It is a symbol of humanity's quest for knowledge and the endless curiosity it inspires about the nature of existence. The LHC's work raises profound concerns and existential and moral considerations. However, it also shows that by working together under careful oversight, we can unlock secrets that may alter the course of history. As we stand on the edge of these new discoveries, we must remain constantly aware of the potential dangers and committed to the ethical use of the knowledge we uncover. The search for knowledge must always be guided by the responsibility to protect our future. In embracing this responsibility, we are not only safeguarding the integrity of science but also honoring the very principles that have driven human progress for centuries: curiosity tempered with caution, ambition grounded in ethics, and innovation informed by accountability. The LHC, as monumental as it is in scale and ambition, represents just one chapter in a broader narrative, one where humanity continuously pushes the boundaries of what is known. Each collision, each spark of energy within its 27-kilometer ring, echoes our relentless desire to understand the fabric of reality itself. But that pursuit is never without cost or consequence. It's imperative that education and public engagement keep pace with scientific progress. As discoveries emerge, so must dialogue, not just among scientists and policymakers, but within communities, classrooms, and homes. The public must be empowered to understand both the promises and perils of such research, so that democratic oversight can coexist with scientific freedom. Moreover, we must prepare future generations of scientists not only as researchers and innovators but as stewards of knowledge. This means instilling ethical literacy alongside technical expertise, encouraging them to ask not only can we, but should we. It means fostering global frameworks for cooperation, where data is shared openly, and research goals are aligned with the well-being of all people and the planet. As we build even more advanced instruments, successors to the LHC, perhaps exploring energies we once thought unreachable, the questions will grow deeper, and the stakes higher. Will we uncover particles that rewrite the standard model? Will we detect evidence of multiverse, or perhaps even signals beyond our comprehension? What then? In such a world, where our understanding of existence itself may shift, one constant must remain: our commitment to wisdom, restraint, and unity. For while the LHC may be a technological marvel, it is, above all, a human endeavor, one born of imagination, collaboration, and a shared yearning to find our place in the cosmos. And so, as the LHC continues to probe the edges of space and time, let us also look inward, to reflect on the kind of future we are building and the values that will shape it. The universe may be vast, but our responsibility within it is profound.